Good morning. Hi, everyone. What an incredible morning the day started with. I'm going to have Lean On Me stuck in my head for the rest of the day. I know that. It was a beautiful gospel band to kick things off, and then Abhishek to welcome us. And then, first for me, I get to follow a governor on stage here, so that should be fun. A little intimidating, but really amazing to hear from Governor Edwards talk about some of the challenges that he faced running a state like Louisiana with respect to a lot of the solutions that you guys are all developing and bringing to market today. So very appropriate and very excited. And I have to agree with him that even though I flew in from Denver yesterday, which is where Maxar is headquartered, not feeling too good about the Broncos tonight. I think the Superdome is a pretty tough place to play. So any New Orleans locals here, good luck, and I think you're going to be okay. So Maxar, just like AiDASH, we take a satellite-first approach to solving the world's problems, to saving resources, to saving lives, to saving time. No surprise there. We own and operate a constellation, an ever-growing constellation of satellites that are conducting Earth imaging missions on a day-to-day basis. We started 2024. It was a huge year for us with 4 satellites in orbit. We've launched 4 since then, and we have 2 more ready to go that we're going to be talking about soon. So even if you're not from the space industry or the satellite industry, you've seen our imagery before. Whether it's looking at a news outlet, whether it's hailing a cab or a taxi in Uber, whether it's looking for a trailhead, you've interacted with our satellite imagery. You're all holding it in the pocket with your phone today. And so specifically, how do we collect all that data? Well, we have this constellation that collects 3.8 million square kilometers of imagery on a day-to-day basis. And I'm going to show you guys kind of what that looks like in just a few minutes here. We collect 1.4 billion square kilometers every single year. And to put that into perspective, that's the Earth's landmass roughly 10 times over. And so one of the first questions I often think about in my job is, what do we do with all that data? It's an incredible amount of imagery. It's 25 petabytes going back to 1999. You could never look at all that with the human eye. You could never sit down and have a team of analysts, even a team of 1,000 analysts, look at all that imagery. So we rely on industry partners like AiDASH to develop industry-leading solutions that rely on technology, on AI, to scour that imagery, to look for the most important objects, whether it's vegetation encroachment or asset management or the numerous other applications that folks have with our satellite imagery, to really have answers as opposed to just pretty pixels. So I mentioned 3.8 million square kilometers. Does anybody know what 3.8 million square kilometers looks like? Well, if you put all that together, it's about the size of India. And that's what we collect on a daily basis. But that imagery is actually spread around the entire planet. So our satellites, and I'm going to show you an animation soon of what these orbits look like, but they're orbiting the planet every 90 minutes. But they're not just collecting what's directly below them, or at nadir, as it's called. They're constantly looking at different objects and understanding what's the most important areas of change or population centers or responding to natural disasters and emergencies to make sure that we collect and provide the most important information on a daily basis. So this is what we've collected in the last day over North America. I'll admit this isn't the most impressive graphic that I'm going to show today, but this is our last 24-hour collect. And as you begin to expand that, this is what we've collected in the last week. And you start to see some really interesting patterns as you look further back in time to what we've collected. For example, you can see here in northern Minnesota and in northern Montana, it looks like some corridors, could be gas lines or transmission lines. It could be a collection that we've made for AiDASH or for some of the folks in this room. But this is an example of what we collect every week, every month, and every 6 months. And if I expanded this out to every year, it would cover virtually the entire Earth's landmass. So we're constantly trying to maintain that very fresh database of what the Earth's surface looks like, whether it's with an annual refresh, a weekly refresh over a lot of population centers, or even multi-day collections over some of the most important and changing parts of the world. And the way that we're doing this today, and the way that we're going to make sure that we can do this tomorrow, is by continuing to launch more satellites. The 4 that I mentioned earlier that we've launched this year are part of our Legion constellation, which is our next generation Earth imaging constellation that once complete, which is going to happen later this year, early next year with another 2 satellite launch, we will have up to 15 revisits per day of certain areas on the planet. And so we're going to have 10 satellites in orbit, collecting at different, or orbiting the planet on different orbits, and collecting different imagery based on different customer use cases. All the imagery that we're going to be collecting is at what's called a 30 centimeter class resolution. That means that when the satellite is looking straight down or at nadir, the size of a single pixel is 30 centimeters, or roughly 1 foot. And so it's the highest resolution commercial Earth imaging satellites that are orbiting the planet today. And this triples our existing 30 centimeter capacity, which is incredibly exciting. When I first started at this company 14 years ago, 50 centimeter imagery was the best that we could collect. And we had a couple of satellites that were collecting that. And when we first launched WorldView 3, our first 30 centimeter satellite, it was really a game changer for us. And it opened up a lot of new use cases and enabled folks to answer a lot of questions that they didn't think they could ask of satellite imagery. So to stand here today and talk about how we're going to triple that 30 centimeter capacity so that we can collect, as Abhishek mentioned, there's over 1 million linear kilometers of transmission lines that AiDASH has monitored, or of transmission and distribution lines that AiDASH has monitored over time. We're excited to have that continuity and that additional capacity to collect all that demand. It's also a very high accuracy constellation, so that when we collect a transmission line or we collect a single tree, you can be confident that that tree is within a few meters of where it's demonstrated in that image. And so it wouldn't be a good satellite imagery presentation without some pretty pictures. This is one of my favorites. This is actually a water park in Pyongyang, North Korea. They do have water parks in North Korea. It's pretty beautiful. This image was just taken about 2 weeks ago with our new WorldView Legion constellation. So for many of you, these are probably going to be the first images you've ever seen collected from our WorldView Legion satellite, but incredibly exciting to have these on orbit collecting these beautiful images. This is one that was collected, one of my favorites, just 18 days ago at Cape Canaveral. This is a ULA launch of a rocket, and you can see just the incredible level of detail at Launch Complex 41, which is actually the same launch complex I was at back in May of this year when we launched Legion satellites 3 and 4, which are now going through commissioning and getting ready to begin downlinking that data. Here's an image of some floating top oil tanks in Singapore. Really incredible imagery where you can begin now at this resolution to measure the volume of these oil tanks based on the shadow that the floating top casts. So if you look at this image specifically, you can see where that floating top is on top of that oil, and you can begin to do things like volumetric analysis and predict what oil stores look like around the world. Something that is very challenging to do at scale with something other than satellite imagery. An oil tanker also off the coast of Singapore. And just kind of a fun shot of Buckingham Palace in London. If any of you were there this summer and you were visiting on July 31st, you may see yourself in this image trying to get one of those guards to flinch. Pretty tough to do that, I think. So these Legion satellites, I mentioned that we launched 4 this year, 2 more to come. This is a pretty exciting time for us. These satellites were built in-house by Maxar, and there have been some delays, which is rather customary in our industry, but we're very happy to have these in orbit now, and this is a pretty exciting shot of the first 2 Legion satellites. When we launched these satellites, our chief operating officer, who has been running the Legion program for a number of years, he says he doesn't breathe for about an hour. So we launched these satellites, and just because the rocket has a successful launch, there's a lot more that has to happen, right? The satellite has to successfully begin its orbit around the planet. It goes through an autonomous process of commissioning to turn itself on, to make sure that the power units are in operation, to make sure that the lens is in operation. And we got these pretty incredible images from SpaceX after launch so that we could actually see that it did have a successful deployment. And this was a pretty helpful picture for us to start to understand. But to see an image like this, to see the rocket that brought the satellite into orbit, to see that satellite and then to see that Earth behind it, to me is just so incredible to put into perspective exactly what it is we do. Our third and fourth WorldView Legion satellites are going through a commissioning process right now. Those are the ones that were launched in May. And then, as I mentioned, Legions 5 and 6 are coming very soon. So incredibly excited for that launch coming up, like I said, near the end of the year, early next year. But that's a launch you can all watch live. I think SpaceX live cast that. Pretty exciting to watch, especially if you're in this industry. So this is what those orbits look like. And this is an actual representation of the entire 10-ball constellation that Maxar is going to have active in just a few short months. And what you can see here is a couple of different things. One, we're really focused on Paris. We picked a location here that shows you what that 15 revisit per day looks like. And so these are all the different times a day that this entire constellation will have a physical access over Paris. Now, historically, we have operated a constellation that was all in what's called a sun-synchronous orbit. And that means that these satellites orbit every 90 minutes over the north and south poles, and they also collect at roughly between 11 a.m. and 1 p.m. local time. And that's very much intentional. The sun is our flash, and so when we collect imagery, we want to have the sun as high in the sky as possible, and so we collect at midday. But now with these new Legion satellites that we're launching, 4 of them will be in what's called a mid-inclination orbit, which means that instead of orbiting the poles, they will be in more of an equatorial orbit, and they'll actually stay between 45 north and 45 south latitude, which means we're going to get a lot more capacity and a lot more revisit over those very high-value latitudes on the planet. Over 90% of the Earth's population lives between 45 north and 45 south. So we're aligning our constellation to collect what matters to everyone. And so I mentioned this notion of 30 centimeter resolution. That's the spatial resolution. How much can you zoom in on an image? But there's other metrics that matter. It's not just what is the spatial resolution. There's also what's called the spectral resolution. So it's not just what can you zoom into, but what else can you see? And so you can see beyond what the human eye is able to detect. On the left side of the screen here, you can see a natural color image of the Dixie Jumbo wildfire that was burning in California in 2021. And what you can really see here is some haze, some smoke, and some vegetation on the ground. But when you sample that same image using a near-infrared band as a color infrared image, you can now very easily detect healthy vegetation, which is represented in red in this image here. And so I was thinking about Governor Edwards' presentation he gave earlier, talking about all the trees that have died here as a result of the drought in the past year, and how now instead of just going out and limbing and pruning trees, they're actually trying to manage entire trees that they have to cut down. You can see at the individual tree level what tree health what vegetative health looks like when you leverage these broader spectral bands that these satellites collect at. And you can go even beyond the near infrared into what's called the shortwave infrared. This is an incredibly effective tool for doing things like identifying where fire hotspots are, whether they're wildfires or they could be methane seeps. But the shortwave infrared is actually able to detect these type of hotspots, and they can see through clouds. They can see through smoke. Can't see through clouds yet. We're working on that. If any of you have ideas for how a satellite can see through clouds, that'd be $1 million idea we'd be happy to talk about. But here you can see shortwave infrared imagery, being able to see through smoke caused by this wildfire so that you can detect exactly where these hotspots are, so that if you have assets in region, whether it's transmission lines or a substation, or if you're a first responder trying to send firefighting resources directly to the hotspot, this imagery provides incredibly accurate and incredibly timely information to assist with those efforts. And then we take this imagery, I mentioned this 1.4 billion square kilometers of imagery. We want to make it as accessible as possible. And so we build a number of different derived products with this data. Whether it's 3D data, as you can see here, this is a view it's a digital surface model of Los Angeles, or you can see building footprints in Lagos, Nigeria, in kind of that yellow gold color. The third one is a change detection map, which is incredibly interesting because when you're looking at all this imagery, what you're typically most interested in is what's changed, right? We have a very deep archive looking back at this planet for the last 25 years, but what most people want to know is, well, what's actually changed since yesterday, since last quarter or last year when we looked at this vegetation? Is it now encroaching on this transmission line, or is this not something I have to worry about? We're running algorithms that can quickly identify change, and we're processing data in a way that enables our partners like AiDASH to very quickly build industry-specific value-added products like you guys utilize today. And then this last one you can see here is a land classification map, so that we can quickly look at imagery and identify what we're looking at. Is this a developed area? Is this a wetland? Is this a prairie? And begin to classify specifically what this surface looks like, and then we can look at it with the optical imagery to answer some of those important questions. So this is kind of a fun image of a substation. It's fun for us, right? Most people wouldn't think this is a very fun image, but this is a fun image of a substation on the California and Oregon border. And there's a lot going on in this image that I think is pretty fun to pick apart. First off, the big scar you can see in the bottom of the image going from west to east is the gas transmission northwest pipeline that TC Energy manages. So this is a very large natural gas pipeline that provides natural gas from Canada to the United States. And then you can see this substation that we can begin to zoom into, and you can see some of the specific assets at this substation. And this is an image that was just taken about 3 weeks ago. So you can see transformers and insulators, isolators, bus bars, all the different features that you'd be interested in monitoring at this type of substation. And you can actually see the individual transmission lines that are sending that power, and you can see exactly where any vegetation might be encroaching on it for responding. And when you look at that from a slightly different angle, the level of detail is truly incredible. And so our objective is to be able to provide this on a cadence that we're able to detect vegetation encroachment as it occurs to enable folks to respond to this as opposed to walking with boots on the ground. Actually, I have a colleague, Ryan Stage, who's here, who will be running our demo booth, who said that he was previously, a previous job he worked here, and he was walking this as opposed to using satellite imagery, and now he's wearing a boot on his left leg. So I don't know if that's related or not, but we're truly trying to help people out here by alleviating those boots on the ground. Emergency response and disaster response. I showed an example of this in a previous slide, but this is from Hurricane Helene in North Carolina. And so in this specific image, you can see the before on top and the after image on the bottom, and you can see some of the specific distribution lines that were impacted from this hurricane. So you can quickly detect where you need to send resources to reinstill power into these communities. A large wildfire burning in Texas. This is the Windy Deuce Fire in Texas. And so here you can see a very large-scale zoomed-out image. This was a fire that burned 140,000 acres just earlier this year. And as you begin to zoom into the pre-event imagery, you can see Fritch, Texas before the fire, and then you can see exactly what was impacted after the fire. And you can see specifically where those fire lines are, whether they're intentional fire lines that were cut by responders, or it could be roads that were leveraged to act as fire lines, but very effective in managing disaster response. And then this is one that hits very close to me at home. This is a fire. It was the most destructive fire in Colorado history. It was burning 3 miles from my house at the end of 2021. This is the Marshall Fire, which destroyed over 1,000 homes, caused $2 billion in damage. And there's an ongoing investigation, actually, of both this fire and the Windy Deuce Fire as to what caused it, with Xcel Energy, kind of in the as part of that inspection, if it was caused by distribution and transmission lines, which is often the case. And so these are examples of some of the things that we're trying to prevent and trying to help minimize the effects of in our partnership here with AiDASH. And this was just an incredible shot of the fire burning in real time, ripping through this neighborhood. This is one of those neighborhoods in Louisville, Colorado, a before image, and then what it looked like 2 weeks later, every single house was completely destroyed. So a really, really traumatic fire near our headquarters in Colorado. And we don't just collect this imagery in Colorado or near us at home. We're obviously very global scale. And so I'm just going to finish with a few shots of monitoring and managing energy infrastructure around the world. Here in the Maldives, in Russia, a gas processing plant, a nuclear power facility, the Zaporizhzhia, I was working on that earlier, the Zaporizhzhia nuclear power plant that has been a very key plant in the war between Russia and Ukraine. Here you can see an oil field in Libya, a solar energy facility in Texas, a wind farm in Texas, and some transmission lines, once again, kind of to bring this back home in Boulder, Colorado. So monitoring all types of different energy assets around the world. So thank you very much for letting me take the stage here and spend some time with you. I believe we are up with AiDASH. Thank you.
I am Rahul Saxena, co-founder and Chief Product and Technology Officer. Thanks, Josh, for this nice presentation around what's possible with satellite imagery today. What I would be doing is deep diving and building more on how we have married at AiDASH the satellite technology and AI to enable all these different use cases for utility operations and reliability. To start with, some of the technology trends which have been shaping the future of how we secure the critical infrastructure would focus on three things which we are combining here. The first one, of course, is satellite. That's what the session is about, how the satellite launches are increasing and the resolution is improving. Second is the massive compute power, which has ushered this AI era. Third is just too many models which have evolved over a last period of years. We are seeing a lot of these LLMs, large language models, and all that. Maybe double-clicking on these a bit more. So as of today, Josh talked about different satellites which were more on the optical side, but if you look at the statistics, the satellites in general across optical and different spectrums are increasing. So this was one statistic which says that there are 1,000 satellites which are launching into orbit each year, and the resolution keeps improving. That's what the graphic shows there. With all this data available, how do we make these different use cases enabled, right? So for that, we need a lot of computing power. So we are talking about the operations which are required to make this AI operations possible. So this data shows the compute power or the number of operations in petaflops. Petaflops is 1 quadrillion or 1,000 trillion sort of operations, which are increased from 314 million to 2.7 billion to 2.7 billion operations. Additionally, with all these operations possible, you are able to do much more. If you look at the history from how the models have evolved. So again, in the training compute or the flop side of things. So it started with AlphaGo Master back in 2018 to now you see the evolution of models. These are all multi-model sort of functionalities which you can build on. There are language models, large language models, which are enabling ChatGPT and Google Gemini and that sort of stuff. There's speech. There's obviously a lot of things around vision. So we have a proliferation of all these AI models, which enable the sort of use cases which we are talking about here. So that all goes in the AiDASH platform. Now, demystifying how we have built this platform and married all this satellite and AI first, make it an AI first platform. So in that sense, we are talking about getting all these different data sources. We talked about satellite, but it's also about not just the satellite imagery, it's also about as utilities there or different sort of customer bases, there are different data which is relevant, which needs to be married with the satellite. Additionally, apart from satellite for different sort of use cases, you need to add some more data, the geospatial and third-party data. So that's what we fuse. Based on that, we are making these vegetation AI models, which enables our product suite. So again, double-clicking on these again. So when we talk about enterprise client data, we are talking about all these different data. So for example, for utilities, which most of the folks are here from, we're talking about network data, how the network graph looks like, for the area of interest, how the feeder and the whole utility network looks like, how are they connected, what's the data around the past outages, maybe customer count, maintenance specs. All this feeds into the model, additional to the satellite imagery. That's required for us to pinpoint and give laser-focused analysis. Additionally, for other industries like land and construction, wastewater and wastewater companies, this is more around the biodiversity net gain sort of use cases. But yeah, again, there, land data, ground survey data, maintenance specs, everything is required. So we take this into picture. This is more deep diving into how the end-to-end pipeline looks like. So we are talking about multiple stages here, right from data acquisition to the code feature generation. So data acquisition, we're talking about multiple algorithms here. So first of all, it's about getting data connectors with all the satellite providers, how we write APIs to integrate, what sort. So typically for utilities, the areas are potentially much larger. So what we want to do is when we want to figure out feasibility of what's available in the past, like Josh mentioned about, there's archive of rich data available. So you want to look at, what's there in the past to enable different scenarios like change detection. You want to, look into what is it that you want to task and get for the future and the current imagery. So what we have built is we have built these connectors to all these different vendors. And what we also have is an optimal storage backed by data lakes and all these different typical data sort of a platform which we have. Additionally, we have algorithms like optimal AOI. So typically when satellite vendors are looking at collecting the data, these are all square blocks, but power utilities are not square blocks, right? So we are looking at safeguarding power lines, which would be lines. So we have built this algorithm over a period of time, and some of these are patented. So where we can, take the power lines, take the area of interest, and figure out what exactly to ask for to ensure the costs and efficiency metrics are there. When we talk about getting this data, we are talking about different imageries, multispectral, SAR, synthetic aperture radar, hyperspectral, thermals. All of these are getting possible as we go forward. Once all these imagery are there in the system, we apply different data transformation techniques. So this has to work at scale, so there is a distributed data processing involved. There are quality checks in place. So just, again, referring back to Josh, he talked about this scenario around cloud and, that not enabling us to see through the clouds. So what we do is when we get this imagery, we have our own checks and balances inbuilt that, let's get the right data in place and then apply the models on it. Otherwise, the models won't give the right output. And there are different data imputations we do on top of that. After all that, we have different core feature generation or AI algorithms with some things, just to name a few, like semantic segmentation, object detection, change detection, and different sort of classifications. So that's what the platform does overall. And the third part we talked about was we also enhanced this by adding more data. So it can be drone and aerial, it can be LiDAR, it can be weather and soil, or vehicle-mounted sensors. So all of this combined basically runs into the model, and we get all these different sort of outputs, which we call vegetation AI. So these are all which are relevant for the utility use cases for the vegetation management. So things like tree height, tree health, next trim year, vegetation density, equipment type, clearance models, wildfire criticality, and storm criticality. So all of these are enabled by the platform as of today. So again, deep diving into, Abhishek covered AI for the entire grid in the morning. So maybe just giving a glimpse of what that means for us and how we are enabling it. So that's what he covered earlier. So basically, we are building a unified approach for grid inspection and monitoring, which is a sort of a two-step process. So you do a complete satellite scan of the network, where we are looking at, getting all the vegetation AI models enabled. That's what we do today. What we are also looking at is once we have done that analysis and combined with historical data, utility data, and all the relevant data, can we do a need-based scans with all these different sensors, right? So in total, combining all of this, make it more efficient. So again, we'll take a short example here. So if you look at it, this is, for example, an example of a satellite full scan, which we have done for a network. This was for, among other things, tree hotspots identification and figuring out the vegetation encroachment and other use cases. So we typically take the 30 centimeter satellite imagery or 50 centimeter, whatever is available best, and combine it with the aerial DSMs, which helps us classify and build all this data around the network. If we want to deep dive, that's the next level scan, we can actually go deeper. So for example, let's say we are talking about a full network scan of this area. We want to deep dive and we feel, there are some areas where we really want to deep dive on from asset inspection and other use cases perspective. So we can, let's say, merge mobile LiDAR here. So for this, you would have figured out from the previous satellite scan that, which are the areas which are road accessible versus not. If they are, you can, let's say, take a mobile LiDAR fitted on a car. You can then get into really deep into these sort of data. You can actually go even deeper and look at a damaged pole, a tilted pole, or a rusted pole. So those are the sort of use cases we are looking to enable via our platform as we go forward. And once we merge all of that, that's what the platform is all about, right? So it's a full network scan for first, then need-based scans for the use cases we are looking at by all these different sensors. And combining all these insights, And like I mentioned, so when we do the full scan, you can figure out where the road accessibility is. So based on that, you can send the sensors. You can, where the road accessibility is not good, you can do, let's say, do aerial scans. You can also figure out there are pockets. Can we do drone-based scans there? So all of these, the idea is to comes together and enables this AI as we were talking about, and enables all these different use cases, whether it is vegetation management, whether it is asset inspection, whether it is climate risk. Yeah, that's what it enables. Yeah, so from that, I'll wrap up the session here, by combining all this. So this is what the platform is. So we have demo booth set up here. We have folks here who can get deep dive into this. So yeah, join us in securing tomorrow. And happy for any Q&A.